Go on, duck, everyone. Iceland is a small island country that is located between Greenland Sea and also North Atlantic Ocean. The capital city of Iceland is Reykjavik, which means Smoky Bay because of the hot springs. So most of them are speaking Icelandic, but also they speak in English, and 93% of them in Iceland are Icelandic.
Iceland is also known as the land of fire and ice because of its volcanoes, lava field, glacier, and fjord. Lava cover 11% of the land, while glacier cover 12%. The landscape is wild and beautiful, but only 20% of the land is livable. But most of its people live along the coastline. Even with its harsh environment, Iceland has high quality of life. It offers free education, great healthcare, low crime rate, and high global happiness and peace index.
And this is the table of the population in Iceland since 2004 until 2024 for the 20 years. And we can find the pattern of the population growth in Iceland by using the mathematical modeling. From the change of the population to the change of the time, we can find the constant for the population growth. And to finding the constant k, we need to integrate both solution, and from this integration process we will find the p equals to plus minus e power of c and e power of kt. So how to find the k? We just take the plus minus ec, which is we can simplify it as a value of k. So we just insert the any of our population data such as make it as a reference to the initial year, which is the 0, and we can make the value as a value of a, which is the a equals to 292,074. And from this we can insert the value of a, and then finally we can find the value of k, which is the k equals to 0.01558. And here this is not the actual value. To find the average value of k, we need to find the each value of k from the each year we have in the population of Iceland. So from this all of the k value, we can find the average by sum of it and over it with the total of year, and then we can find the average k value, which is the k equals to 0.040146. And from this equation we can find the population of the Iceland through the mathematical modeling, which is approximately equals to the actual value of the population inside this duration of year. We can obtain a graph that replicates approximately equals to the actual value of the population in Iceland, where we can see that from this graph we can extrapolate it, so we can find the future and the past value, although we don't know the actual population in that area.
Now we're going to calculate the percentage of error for the past and future value of the population in Iceland. For the future value, we take t equal to 10, which represents the year of 2014, and the estimated value for the population in Iceland is 337,986 with a percentage of error of 3.23%. For the past value, we take t equal to -1, which represents the year of 2003, and the calculated value is 287,480. The population recorded in 2003 is 289,521. And this differs 0.58% from the calculated population.
The difference occurs because the real world situation are not fully captured in the mathematical model. So there are some factors that affect the growth of the population in Iceland. The change in government policy like immigration control or family planning programs. Economic instability also, such as recessions or financial crises that affect the population decisions. Migration trends. The people coming in and coming out from the country also affect the growth of the population. Health crisis can reduce the population or slow down the growth. So for example, in 2008 into 2011, there are major banks collapse, the currency drops, and also the inflation getting worse, making the people of Iceland moving out to the country to find job opportunities that can help them to survive. In fact, that is the main reason why the growth of the population in Iceland drop from time to time. Future population depends on things like immigration. More people or skilled workers or students coming in can help in growth of the population. Besides, a strong economy also can attract more people to coming in into the country. And other than that, a good healthcare means people can last longer in the country. And as of 2021, the government provide a 6-month parental leave to each parents to grow a good family.
In conclusion, Iceland's population growth is influenced by several factors, including economic conditions, immigration, and birth rates. The 2008 until 2011 banking crisis played a key role in slowing population growth due to economic struggles and a decline in birth rates. In the future, immigration, a stable economy, and government policies will continue to shape the population trends. Climate change, technological advancements in healthcare, and potential shifts in birth rates will further impact the nation's population's dynamics. Despite past challenges, Iceland's population is expected to grow steadily, driven by these factors.
Sir, can you explain me what is the Newton-Raphson method?
That's a very good question. Now I will begin to explain the Newton-Raphson method. Basically, Newton method is the application of polynomial for finding roots of functions. And this way is to find a quickly good approximation for the root of a function, which is function equal to 0. Okay, so this is the Newton iterative method. Okay, we will use the Newton-Raphson method to obtain the root of the function that we already get, which is the interval is between -2 until -0.6, and we will state the answer about 5 decimal places. Okay, so we will take the left hand side to right hand side at the equation function to make it equal to 0, and after it we will differentiate it multiple times again and again. We will do it repeatedly until we get the constant value of the root.
To find the constant value of a root nonlinear equation from the given question, we decide to insert the function from the question and its derivative in Excel. Firstly, create a table consists of 5 columns and at least 5 rows, but we decide to put 10 rows to make sure the value of root stays constant. And then this is the column of x, the column of function, the column of derivative function, and the column of the root value of each interval of n. And then the equation of function is x power of 4 over x plus 4 plus 2x squared times with sin 3x. The equation of derivatives, 3x power of 4 plus 16x cubed over x plus 4 squared plus with 4x times with sin 3x plus with 6x squared times with cos 3x. And the equation of the root value is x minus function over derivative function. And then you can just copy the formula or type it out yourself and then insert it in each column. Same goes for the derivatives, the root value, and then we can put our intervals from -2 to -0.6. Negative 0.6. We decide to put -1, and this all is in 6 decimal places because we want to round off the root value to 5 decimal places. This is the root value of the first interval, and then in this second row, press equals and select this row, and you will get the value of the second row. And then we select these and pull it downwards, and as you can see, starting from the third row, the value of the root from the nonlinear equation stays constant. There you go. Thank you very much.
As we can see, we use the Newton-Raphson method to find the approximate value. We take the initial guess, which is x equal to -1, and then we substitute into the formula, and this is the result shown of our approximate x. But we stop at the x4 because x4 and x3 have the same answer. Therefore, the approximation of root is -0.99338 in 5 decimal places. And this is our graphical illustration of our method. The red curve represents our function and the blue line represents our iterative process. Therefore, the Newton-Raphson method finds successfully better approximation to the root of a real value function, which is equal to -0.99338. To conclude, the Newton-Raphson method was effectively used to find the root of a nonlinear equation. Looking ahead, this method can be a valuable tool for solving complex mathematical problems in fields such as engineering, physics, economics, and computer science. With a proper understanding of its limitation, we can also apply it to a wide range of practical problems in the future.